Hello students, soil acidity and alkalinity are closely related to soil fertility and plant growth. First, it affects the growth and development of plants. Soils with excessive acidity and alkalinity are not conducive to plant growth. Second, it affects the availability of soil nutrients and the activity of soil microorganisms, thus further affecting the physical and chemical properties of soil. Today, let's learn the determination of soil pH and discuss the adjustment methods. There are three methods for soil pH determination: potential method, mixed indicator method, and pH test paper. Next, the potential method. The principle of potential measurement is to extract water-soluble hydrogen ions or exchangeable hydrogen ions and aluminum ions from soil with water or neutral salt solution, and then measure the potential difference of the leaching solution with indicator electrode and another reference electrode. Because the potential of the reference electrode is fixed, so the potential difference depends on the hydrogen ion activity in the test solution. The pH value can be read directly on the pH meter. Before determination, prepare pH 400 pH meter, standard puffer solution, 1 mm air-dried soil sample, 50 ml beaker, 25 ml measuring cylinder. The determination of steps. First, prepare soil aqueous extract. Weigh 10 grams of air-dried soil sample passing through a 1 mm mesh. Put it into a 50 ml beaker. Add 25 ml of carbon dioxide-free distilled water. Pour pure water into a measuring barrel. Stir vigorously with a glass rod for 1 to 2 minutes. Then leave it for 30 minutes, and then measure it on the computer. Repeat it 3 times. Pay attention to soil pH value less than 70. Soil potassium chloride leaching solution should be determined. The pH meter should be calibrated before measurement. Start the instrument. Measuring buffer temperature. Manually adjust temperature compensation. Press the calibration mode. Put the electrode into the buffer solution with pH 6.86. Gently stir and stand still. Press Enter key for calibration after the reading is stable. Clean the electrode with distilled water and absorb water with absorbent paper. Take out the electrode after calibration. Clean the electrode with distilled water and absorb water with absorbent paper. Then insect it into the supernatant of the soil liquid to be measured. Stir it slightly and then stand still. Record measured value. Pay attention to the agitation and be gentle to avoid turning into the soil below. When the reading is stable, the measured value recorded is the pH value of the soil liquid to be measured. Repeat the measurement 3 times. Next, the mixed indicator method. The principle of this method is that the indicator can display different colors in different pH solutions. And the pH value of soil solution can be determined by comparing the displayed color with a standard acid-base color chart. This method is simple, convenient, and can be quickly determined in the field. Preparation before the experiment. White porcelain color metric plate. Standard acid-base color metric card. Acid-base indicator. Experimental procedure. Take plow layer soil from different position in the field. Mash it and mix it evenly. Pay attention in order to avoid the measurement error caused by acid or alkali pollution. Of white porcelain color metric plate on the way, the soil sample to be measured is generally rubbed and cleaned 3 times before measurement. Take the soil sample of soybean size to be measured and put it in a clean white porcelain color metric plate hole. Add 3 to 5 drops of indicator so that the sample can be completely wetted and there is a little surplus. It is advisable to shake it horizontally for 1 minute and place it for a while. After clarification, tilt the porcelain plate to compare the chromaticity of the solution with a standard color chart to determine the pH value. The principle of measuring pH of test paper is the same as that of mixed indicator method, so it will not be described here. Although the acidity and alkalinity of the soil have an impact on the physical and chemical properties of the soil itself has a buffering capacity. What is the buffering property of soil? It refers to the ability of soil to resist drastic changes in acidity and alkalinity caused by foreign substances. Soil texture, soil organic matter, and soil colloid types are the main factors affecting soil buffering capacity. Because the soil has buffering property, the pH value of the soil will not change drastically under natural conditions because of the exchange of external condition, which is beneficial to the normal growth and development of plants. Acid-alkali soil is not conducive for plant growth. The main measures to be improved are 1. Acidic soil. Quicklime can be used to improve quicklime, which is a strong alkali. It can't contact with plant roots to avoid burning seedlings. Shelly ash containing calcium can be applied in coastal areas. Apply physiological alkaline or alkaline fertilizer. At present, hydrated lime is widely used as a chemical modifier for acidic soil. Note that lime should not be fixed with fertilizer. 2. The content of exchangeable sodium ions in alkali soil is high. In production, gypsum, alum, sulfur powder, alum ferrous, sulfate, physiological acid, or acid fertilizer are used to improve alkali soil. Full layer application methods should be adopted when applying gypsum in heavy alkali. Okay, that is the main content of this lesson. See you!